Hello, can you hear me? Hello.
Hello.
Yeah, you can hear me, right?
Yeah.
Okay. I had sent the questions. I hope you got it. Question 4, 5, and 6.
Uh,
Yesterday I had sent screenshots. Did you see?
oh yes. Yeah.
Okay. So, fine. Question 4 is what is the least number of factors you have to remove? Number of factors to remove out of 99 factorial so that the product of the remaining factors ends in 2. Okay.
Um, Pretty much first you have to remove all the factors of five because those will make the number end in zero.
Hmm. 0 or
So
5.
yeah,
So how many
and there
factors of 5 will be removed? How many numbers have to be removed?
it's
Basically starting from 5, 10, up to 95, right?
yeah,
So there's 19 factors that have to be removed.
Hmm. But then it's still not guaranteed that it ends in 2.
yeah. But then you end up with 10 numbers, 10 factors that end in each digit besides five and zero.
Mm-hmm.
And then well, what I did was I checked if you if you raise each digit to the power of 10, what will the last digit be?
Why are
So
you
I got
raising it to the power of 10 though?
because there'll be 10 factors that end in each digit.
But that is not the same as saying 5 power 10. Like for example, you are saying 2, 12, 22, and all, right?
Yes.
Yeah.
So you are saying that the product of these ends in 2 power 10, the last digit.
Yeah. The last digit of that will be the last digit of 2, 12, 10.
Okay.
So you get 1, 4, 9, 6, 6, 9, 4, and 1 for 1, 2, 3, 4, 5. 1, 2, 3, 4, 6, 7, 8, and 9.
Mm-hmm.
And those and those give you a product that ends in 6. So pretty much now we need to remove a factor that will turn the 6 into a 2 or like
So
multiple
how?
maybe. But the thing is, let's say if you divide it by 3, you don't know if it'll give you a 6, if it'll give you a 2 or not. But um,
You have to remove the minimum number of factors in order to ensure
Yes.
that the product ends in 2.
Yeah.
So far, what we have done is we have a product of 1 into 2 into 3 into 4, and then 6, 7, 8,
Yes.
9, and then 11, 12, 13, 14, and 16, like this.
Yeah.
By the way, you should realize that whatever is the last digit of this will be the same last digit if we had just done this, right?
Yeah.
Yeah.
All of it is multiplied. The last digit that comes here is 6 into 4, 24, 6, 144, 7. It will be 8 here, then 4, and then 6. Last digit is 6 when you multiply these, right?
Yes.
And last digit is 6 when you multiply these also.
Yeah.
So we can see clearly that every such set is having, we can do this multiplication by doing part multiplications also, right?
Oh, yeah.
Do you understand? You don't have to multiply all of them. You
Yeah.
can multiply just this group and say it's a number ending in 6. This group is a number ending in 6, right?
Yeah.
So actually like this, all the groups are ending in 6, right?
Yeah.
Yes.
When you multiply any number ending in 6 with another number ending in 6, the final answer is also ending in 6.
Yes.
So ultimately, if you can somehow remove some factors from here and make it end in 2, that will be enough, right?
Yeah.
So how many factors do you need to remove? Minimum number.
1. I mean, 10.
You No, you can just remove one, no? If one
Yeah.
group
Yeah.
has a different ending, all of these other groups has ending in 6, right?
Yeah.
Yeah.
I can just remove one number from here such that the final product of this into this should be ending in 2, right?
Yeah.
Correct?
Yeah.
So suppose I remove an 8 here. What is the number ending in now? 6, 4, 24, 4 till here, then 4 till here, then 8 till here, and then 9. 2 ends in 2, right?
Yeah.
If I multiply something ending in 2 with a number ending in 6 here, it will still end in 2.
Yeah.
So basically, one way to do it is to just remove one more 8, and that's it. Don't do anything else. And you will still have a number ending in 2, right?
Yeah.
Yeah.
Because you don't have to change anything here. Let it be, because we want the least number of factors that we need to remove. So 19
Mm.
factors for sure, plus one more. Correct?
Yeah.
Yeah.
Answer is 20.
Uh,
Do you
okay.
understand what is happening?
Yes.
Yeah.
Okay. Question 5 was smallest positive integer n such that n power n does not divide 2008 factorial. If you haven't spent much time on it, then try it now. Otherwise, tell me if you have gotten something.
Okay. Mm, I said like, because you need to find the smallest integer into the end that does not divide
Hmm.
2008.
Factorial.
So 2008 factorial. So that's like the same as saying um finding like the number um mm, um it's like the v of like the VP of n times n should be like less than or equal to the VP of 2008 factorial.
VP of n times n or n power n?
Uh, n power n.
No, E.
VP of n power n should be, if it does not divide, it should be greater, right?
Yeah.
Yeah,
For some prime p.
yeah,
Oh, wait 1 second. No, for any prime p, if this happens, then that number doesn't divide, right?
yeah,
Not just for some prime, for any prime, if VP of this is bigger than VP of this, then we are sure that n power n does not divide this,
Yeah.
right?
Yeah.
yeah.
Okay, so you can check some primes for any prime, right? Uh,
Yeah.
but the n value is not fixed, so how will you think about it?
Um,
See, VP of 2008 factorial is not difficult, but what will you do about the other ones?
Surely VP of n is at least P
It
or
is
N.
at least how much? N,
Yeah.
yeah, n.
right?
So, well, yeah, yeah.
Okay, let's think. Uh, okay, first of all, 2008 is between what squares? So we can check by calculation that it is between 44 square and 45 square. So what that means is that for any n which is n square, for which n square is less than 2008, right?
Yeah.
If n is such that n
Yeah,
square is less than 2008, I think then 2008 factorial will be divisible by n power n. Let's think about why. What am I saying? I'm saying whenever n square is less than 2008, then 2008 factorial will be divisible by n power n. Why? Because think of these numbers,
Oh, yeah.
n, 2n,
Yeah.
3n, and n minus 1 times n, right?
Yeah.
Correct? And
Yeah.
lastly, n square, right? Which is n
Yeah.
into n. So all of these numbers are less than equal to 2008 according to our condition, right?
Yes.
So all of these number will appear in 2008 factorial, no?
Yeah.
Because n square itself is less than equal to 2008. So all of these numbers will be somewhere in the list of numbers from 1 to 2008, right?
Yeah.
Do you understand what I'm saying?
Yeah.
Yeah.
2008 factorial will have the numbers n there somewhere, 2 in there, 3 in there, up to this, right?
Yeah.
So then notice when you do product, already this will give us a n power n.
Yeah.
Can you see why?
Yeah.
How many numbers are here? There are n numbers here, right?
Yeah.
Each of them has a factor of n, right?
Yeah.
So what we can see from here is n power n surely divides 2008 factorial. Correct?
Yeah.
Yeah.
But that happens for every n which is n square is less than 2008.
Yeah.
So when we check, we want this to not divide. Therefore, our n square should be above 2008, right?
Yeah.
So n square should be greater than 2008 for us. So we should start from 45 onwards, basically.
Yeah.
If we want to look at any situation where this will happen, we have to start looking from here, right?
Yeah.
Now we can actually think about it step by step and say ki let's check 45 first, right? 45 power 45 is going to be basically 5 power 45 and 9, so 3 square, so 3 power 90, right?
Yeah.
When we have a specific number, it's not very difficult to check the divisibility, right?
Yeah.
The difficult part was figuring out from where to look also, right?
Yeah.
Now that I know that I only have to look above 45, I will check one by one. So this is this. Now I'll find out V of 5 and V of 3 for 2008 factorial, right?
Hmm.
Correct. So by Legendre's formula, we
Yeah.
can find this, right? 2008 by 5. So 5, find it. Like this you have to find, right? So this gives us a 401, I think. Correct?
Yes.
So notice that it is already much bigger, right?
Yeah.
The power in 5 here
Yeah.
will be 400 plus, right? And the power of 3 will
Yeah.
also be 600 plus, right?
Yeah.
Are you sure it's coming? No, very big.
Yes.
So definitely 45 power 45 will divide 2008 factorial, right?
Yeah.
Let's now check 46. 46 power 46 will be
Oh.
2 power 20, 46 and 23 power 46, right?
Yeah.
When you check V2 and V23 here for 2008 factorial, again you will get bigger values. Do you understand what I'm saying? Are you getting what I'm saying?
Yeah.
The V2
Yeah.
of 2008 factorial and V23 of 2008 factorial will be bigger than 46 for both.
Yeah.
So therefore, again, this number will divide
Yeah.
2008 factorial, right? Finally,
Yeah.
we check 47. When you check 47, now suddenly 47 power 47, that number is itself a prime, right? Correct? Not the number is not a prime, the 47 is a prime. So this is the prime factorization itself, right?
Yeah.
So we have to check V47 of 2008 factorial, right?
Yeah.
When you check this, calculate it and find out what is the value.
Okay.
Yeah, like 43.
Hmm.
Yeah.
So it is smaller than this, no? The
Yeah.
power here.
Yeah.
Yeah.
So basically now it is not divisible, right?
Yeah.
Are you understanding what has happened?
Yeah.
So this question can be actually generalized. So there is nothing special about 2008 number here. So we can say for an arbitrary positive integer m, the smallest positive integer n for which m factorial is not divisible by n power n, right? When will this happen? This was our question. In the question, the value of m was given as 2008, right?
Yeah.
Yeah.
So what we thought about here was whenever you look at numbers where n square, not n square, uh, basically you have to look at primes, p which satisfy p square greater than m, right?
Yeah.
We looked at all the answer for us came as the first prime number that was satisfying prime square is bigger than 2008, right?
Yeah.
Yeah.
Because if you remember, we started by looking at n square lies between what squares, right? 2008 lies between which squares?
44 and 45.
Right. So we looked at
Yeah.
44 square and 2008 and less than 45 square. And then we said that if our n square is less than 2008, less than equal to 2008, or in our case, n square is less than equal to m, in that case, all of these numbers will appear in the sequence of numbers when we write n power n, right?
Yeah.
All of this, when you multiply, you get an n power n directly, right?
Yeah.
So if n square is less than our m, then all of these come in the n power n, and therefore n power n divides m factorial, right?
Yeah.
So when you are looking for n power n not being divisible by m factorial, you have to look at n square greater than m, right?
Yeah.
And when we actually look at the n square greater than m, you will realize that when we compare the numbers n power n and m factorial, most of the time, if it is n is not a prime, the VP of m factorial will be much higher than this.
Yeah.
Right?
Yeah.
But when n is a prime, then the VP of this number is only n, right?
Yeah.
And then VP of this, there is a chance that the VP of this is smaller, right?
Yeah.
That's what happens here. And it is basically the first prime number that satisfies this. That is the answer.
Okay.
I hope you are understanding what we are doing.
Yeah.
Okay. Let's look at question number 6. It was the set question. Set X belongs to n star has the property P. Property P is that every non-empty subset of X has the sum of its elements as a composite number. Right?
Yeah.
You have to look at the set Y, which is equal to this 113 factorial plus 2, 113 factorial plus 3, and so on till 113 factorial plus 15. And we have to show that this set has the property P. Okay.
So what I did was, okay, so I said let's this a subset y1 equal to 113 factorial times n plus k, where n is the number of elements, and then k will be like the sum of the plus twos and plus threes and that.
Mm.
So k is at most 119.
Mm-hmm.
So if k is less than equal to 113, then the subset will be composite because
Why?
it will divide because then k will divide 113 factorial, and therefore k will divide both 113 factorial and
Wait 1 second. You are saying that when you take an arbitrary subset out of this, that subset sum will be 113 factorial times
n.
n is just the number of
And
elements in that subset
yeah, and then
plus 2
k.
plus 3 plus something something, and that
Yeah.
you're calling as k,
Yes.
right?
Yes.
And then you're saying that the maximum value of this is going to be basically 3
109.
plus 15, right? 3 to 15, right?
Yeah.
Okay, subset could be 2 plus also, I think. The
Yes.
subset could be the whole set itself. So
Yeah. And that's fine.
119 you got.
Yeah.
Yeah.
So k is up to 119. And now what?
So
If
if
k is
k less than equal to 113, then
okay,
then k,
113 is a common factor.
yeah, you take this
Is a
common.
common factor so that S is composite. Okay,
Uh,
fine.
then otherwise you just check k equals 100.
Okay, if k is 114, 116, 118, then these are even and this is also even,
Yes. Oh,
right?
all of those numbers are composite. between 114 and 119. Check them all.
But checking them all, you have to tell, no? How?
Well,
For example, what I am saying is for 114, 116, 118, both are even.
yes.
What about for 115, 117, 119?
So
Okay.
for 115, they're
For,
both divisible by 5.
okay.
Uh,
One for 117.
they're both divisible by 3.
And
And
for
119,
119.
it's 7.
Right. They are both divisible by 7. Therefore, in all cases, we are getting that uh, you are getting a composite number. Wait 1 second. If k is less than 113, if it was 112 and all, okay, then you would have taken that number as a common factor.
Yeah.
Right?
Yeah.
Yeah.
Okay, so in all cases, no matter what k values come, you are able to prove that you will always be able to make it composite, right?
Yeah.
So then this set has the property P.
Yeah.
Okay, that is correct. Question 7. Which of the numbers is greater? Which number is greater? 100 factorial or 99 factorial to the power 100 factorial multiplied by 100 factorial to the power 99 factorial.
Mhm.
Obviously, these numbers are super huge. You cannot think about, yeah, you have to figure out some way to measure it or compare
Yeah.
them. Try to use a substitution or something. You can simplify the question a little bit. For example, I would suggest A is equal to 99 factorial. Then what is 100 factorial? It is 100 into 99 factorial, right?
Yeah.
So it is 100A.
Yeah.
So this becomes what? 100 factorial, 100A factorial, right?
Yeah.
And this becomes what? A power 100A multiplied by 100A to the power A,
Yeah.
right?
Yeah.
Yeah.
Okay, fine. Then, so basically this is 100A to the power A. Hmm. Okay. So what we can do here is think of this as whole to the power A of what? A power 100 into 100 A, right?
Yeah.
Correct, no?
Yeah.
Hmm. But that won't work. We have to compare this and this. Maybe try dividing, right?
Yeah. Oh.
No. Uh, or uh, we cannot use V of P of something here because we don't know. Even if V of 2 of one side is bigger than the other side, what if V of 5 of the other is bigger, right?
Yeah.
Yeah.
We cannot use that. So we have to think of some other way. Let's think.
Oh, can't you take away 100A from both sides, and then you get 99A factorial on the left, and A to the power of 100A
No, you get
times.
100A times 100A minus 1.
Oh, it's 100A minus 1.
It's not 99.
Oh,
Okay, it's a little tricky. Let's think. So this is like saying a power a power a 100 times, right?
Yeah.
Yeah.
And this is like a plus a plus a 100 times power a, right?
Yeah.
Okay. So mm, a power a power a. What if what if in each of them I put in a 1 a power a, 2 a power a, 3 a power a, or not 2 a power a. I am saying 2 a power a, 1 a power a, 2 a power a, 3 a power a, and this is 100 a power a. Suppose I have done this. Basically, I have multiplied by some things, right?
Yeah.
I have multiplied by
Yeah.
1 power a, 2 power a, 3 power a, 100 power a, right?
Yeah.
So I am dividing it also. And here I have 100 a power a, right?
Yeah.
Correct? No, this I have not changed.
Yeah.
Uh, by the way, this is what? This is 100 factorial power a, right?
Yeah.
Yeah.
So 100 factorial is basically 100 a, right?
Yeah.
Right? So this is
Yeah.
also 100 factorial power a, no?
Yeah.
Can you see?
Yeah.
Oh, yeah.
So basically, uh, what I did was I have put in a 1, 2, 3 in each of these terms, 100 a per a and all, right?
Yeah.
And then I divided by those things, right? And when
Yeah.
I
Yeah.
simplified it, I realized that this is canceling this, right?
Yeah.
Correct.
Yeah.
Yeah. Okay.
So basically, this right hand side is equal to this, no?
Yes.
Okay. Now I have to compare it with the left hand side, right?
Yeah.
Right hand side, I have a power a, then 2a power a, and so on till 100a to the power a, right?
Yeah.
And I have to compare it with this. Correct?
Yeah.
Correct. Yeah.
Okay. So let's think what to do about that. Uh, maybe 100a was what for 100 factorial basically. Okay, that only is 100 factorial. Huh? So like let's divide and see whether you are getting something bigger or smaller, and think if we get an answer which is clearly bigger than 1 or something, then we'll be done, right?
Yeah.
I'm going to try to think of dividing these two and figuring out which is bigger than 1 or not, right? Okay,
Uh,
so I think what I will do is 100a factorial. Uh, okay, so basically it will be like this 100a times 100a minus 1 and so on. On top, I have only 100 terms, right?
Yeah.
But here I have a lot of terms actually. No, it's just because I'm putting a as this, so that's why. Actually, there are a lot of terms on top also.
Yeah.
Hmm. Basically, we have to figure out how to get this somehow. How can I generate this? 100a factorial. I have to compare with a power a, 2a power a, 100a power a. Okay. Okay, let's look at. I know that k a plus 1 times k a plus 2 till k a plus a will be less than every term. If I replace with k a plus a, it should be less than this, no?
Yeah.
yeah.
Because each term is smaller than k a plus a, right?
Yeah.
So I am replacing all of the terms with k a plus a on the right side, right?
Yeah.
The reason I'm thinking of this is because I'm getting a 2a, 3a, 4a like this here. If I put a
Yeah.
value of k, I will start getting 2a, 3a, 100a.
Yeah.
Yeah.
Do you understand?
Yeah.
Yeah.
So for example, if I put k is equal to 0, I will get what here? I'll get
A plus 1.
1 into 2 into till a
Oh.
is less than a power a, right?
Oh, yeah.
So what am I
Yeah.
getting? A factorial is less than a power a, right?
Yeah.
If I put
Yeah.
k is 1, I'm getting left side a plus 1, a plus 2 till a plus a, right?
Yeah.
Correct?
Yeah.
That's what I'm getting. Is less than 2a power a, right?
Yeah.
Oh, now see what will happen. Can you see that this is the next term in the sequence
Yeah.
after a,
Yes.
right? And if I put k is equal to 2, it will be 2a plus 1, 2a plus 2, and finally it will be 2a plus a, so 3a, right?
Yeah.
And if I go up to 99, I will get 99a plus 1, 99a plus 2, and 99a plus a will be 100a, right? And that will
Yes.
be less than 100a power a.
Yeah.
Can you see that the
Yeah.
product of all of these on the left is actually this?
Yeah.
And the product of this is what we have here, right?
Yeah.
So I'm basically splitting this 100a factorial and I'm writing all the terms in groups of a terms each.
Yeah.
Yeah.
And each step is an inequality involving these a's, right?
Yeah.
I hope you're getting the solution now.
Yeah.
Yeah.
It's a tricky one. This is an actual all Russian Math Olympiad 2014. But it's a nice problem because otherwise, such numbers, how would you even think?
Yeah.
And the starting point was putting a as 99 factorial. After that, there was one nice simplification of the right hand side became much simpler. It became this, right?
Yeah.
Where we grouped the number a to a like that, right?
Yeah.
And then finally, this inequality is solving it. Okay, I'll give you a few questions. You can try these later. Like anyway, you guys have a camp now, right?
Yeah.
Yeah.
From tomorrow, right?
Yeah.
You can try these problems. We'll continue once you guys are back. Find all positive integers m and n where m is greater than n such that m factorial n factorial product is 10 factorial. That's the first one. Find the maximum integer m such that m factorial times 2022 factorial is the factorial of an integer. Okay. And one more we can, okay, two more actually. Question 10 is find positive integers a, b, c, d with a less than equal to b less than equal to c such that 2 power a plus 2 power b plus 2 power c is equal to d factorial. Write down these three questions and we have one final question also. All these questions are based on factorials. That's the topic that we are currently on.
Yeah.
Let a is equal to 1 factorial multiplied by 2 factorial up to product of 1002 factorial and b is equal to 1004 factorial multiplied by 1005 factorial up to 2006 factorial. Prove that 2ab is a square and that a plus b is not a square. This is the question. A and b are given. You have to prove that 2ab is a square and a plus b is not a square.
Oh.
Okay. So these four problems you can try. We will discuss the solutions once you guys are back. And after that, I have one more topic which is about tables and games in number theory. So after your camp, we'll do the tables and games topic. And then we will move on to other topics like geometry or algebra or something. Okay.
Yeah. Thank you.
Okay. Best of luck in the camp. do it properly. Pay attention to what these guys are doing. They will do some sessions from some professors and all, right?
Yes.
Yeah.
Okay, fine. Keep all your handouts and all, keep it ready, like save it properly, don't lose it or something. We can discuss it later afterwards and all, right?
Yeah.
Okay, fine. That's all for now. I'll see
Thank
you
you.
next week.
Bye.
Okay.
Bye.
Bye.